Welcome to this crucial training session. We will be exploring the architecture of Prisma Access, focusing specifically on how its main components, the security processing nodes, deliver protection across your enterprise. This knowledge is fundamental for understanding modern, cloud-native security. Let's get started with the basics of Secure Access Service Edge, or SASE. Prisma Access is built upon the modern concept of Secure Access Service Edge, or SASE. Think of SASE as a unified cloud-delivered platform that brings together two major areas, networking and security. Traditionally, these were separate systems. SASE architecture combines networking capabilities like software-defined wide area networking, known as SD-WAN, with critical security functions. These critical security functions include Firewall as a Service, or FWaaS, which protects your network perimeter in the cloud, and Secure Web Gateway, or SWG, which secures your web browsing activity. It also incorporates Cloud Access Security Broker, or CASB, for overseeing cloud applications, and Zero Trust Network Access, or ZTNA, which grants access only on a strict need-to-know basis. Prisma Access is an SSE solution, providing these security features from the cloud, ensuring advanced URL filtering and threat prevention wherever your users are located. This cloud-native approach ensures uncompromised performance and security at scale. What we have learned in this first slide is that Prisma Access is a comprehensive, cloud-based platform that unifies crucial security and network features into one service, known as SASE. This modern approach is necessary because traditional perimeter security models are no longer effective with the rise of remote work and cloud services. This diagram illustrates the foundation of Prisma Access within the SASE framework. SASE is represented here as a cloud-native architecture. It is comprised of two foundational pillars: networking features such as SD-WAN and a suite of security services. These key security features include Firewall as a Service, Secure Web Gateway, Cloud Access Security Broker, and Zero Trust Network Access. Prisma Access is positioned as an implementation of a SASE solution, delivering these capabilities seamlessly from the cloud. The visual representation emphasizes that Prisma Access combines both networking and security aspects to form a single, comprehensive service. Understanding this unified structure is the first step in appreciating how Prisma Access manages global enterprise connectivity and security. This combined approach is what allows organizations to reduce complexity and save resources by dealing with a single platform instead of multiple point products. Building upon the SASE foundation, Prisma Access utilizes a completely cloud-native architecture, ensuring it is always on and managed by Palo Alto Networks. This massive global infrastructure means that organizations do not have to worry about the complexity of sizing or deploying hardware firewalls at every branch office or data center. Prisma Access locations are spread globally, currently over 100 locations worldwide, ensuring users receive optimized performance and low latency. These worldwide locations are mapped efficiently to specific security compute locations to optimize performance. Administrators primarily manage this environment through a central hub, either the Strata Cloud Manager, which provides a cohesive interface, or through Panorama. The relationship between the customer and vendor is defined by a shared ownership model. Palo Alto Networks takes responsibility for managing the underlying security infrastructure, including maintenance, upgrades, and ensuring resilience. The customer retains control over defining security policies, onboarding users and locations, analyzing logs, and running forensics. This clear division of labor allows customers to focus purely on security enforcement, rather than infrastructure maintenance. What was the core takeaway from this slide? Prisma Access delivers global-scale security using a cloud-native platform managed by Palo Alto Networks, freeing customers from hardware management responsibilities through a shared ownership model. The diagram illustrates the high-level flow and components of the Prisma Access cloud-native architecture. The process begins in the management plane, where administrators use Strata Cloud Manager or Panorama to centrally manage configurations and push security policies. This management system interacts with the global cloud network infrastructure provided by Prisma Access. The network traffic from end users and remote sites is routed through this cloud network to one of the regional compute locations. These compute locations are where the security enforcement actually takes place. The arrows indicate that the management system deploys policies to these compute locations, and the compute locations then enforce security rules on the user traffic. This clear separation of management and data planes, combined with global presence, is key to the platform's scalability and consistent security delivery. At the heart of the Prisma Access architecture are the Security Processing Nodes, or SPNs. These nodes are essentially the cloud firewalls, where all the heavy lifting of security happens. The SPNs are the specific components within the Prisma Access infrastructure that execute the security policies you define, including performing demanding tasks like SSL decryption and advanced threat prevention. Palo Alto Networks takes on the responsibility for managing and orchestrating everything that operates behind these SPNs. This includes automatically managing scaling, continuous monitoring, system upgrades, and maintaining the necessary security subscriptions. When a user's traffic reaches a Prisma Access location, it is directed to an appropriate SPN for inspection and policy enforcement. For instance, in an explicit proxy deployment, the traffic is handled by an Explicit Proxy Security Processing Node, or EPSPN. A recommended practice for optimal EPSPN performance is setting the action in security policies to deny instead of drop or reset, helping release resources quickly. In the following slides, we will detail the three main types of security processing nodes that handle different traffic flows. What is the key takeaway? SPNs are the core vendor-managed compute units within Prisma Access that execute all defined security policies and traffic inspection. The first specific type of node we are looking at is the Mobile User Security Processing Node, or MUSPN. As the name suggests, these nodes are dedicated to protecting users who are connecting remotely or on the go, often referred to as the mobile workforce. Mobile users typically connect to the Prisma Access infrastructure using either the Global Protect app, which creates an agent-based secure tunnel, or by redirecting their browser traffic through explicit proxy. The MUSPNs ensure that these mobile connections receive the same consistent and comprehensive security as users within a physical office. For historical context, in Global Protect deployments that have not utilized the optional IP optimization feature, each physical Prisma Access location you allocate receives one MUSPN. Crucially, the data transmitted between MUSPNs and other major nodes, specifically remote network SPNs, is encrypted end-to-end. This robust encryption guarantees the integrity and confidentiality of the traffic as it traverses the cloud infrastructure. What have we understood about MUSPNs? They are the dedicated security components for securing the mobile and remote workforce, primarily supporting connections via Global Protect and explicit proxy, and maintaining end-to-end data encryption. This diagram outlines the process flow for a mobile user accessing resources through a Mobile User Security Processing Node, or MUSPN. The flow begins with the mobile user's endpoint device. This device establishes a secure connection to the Prisma Access cloud environment using technologies like the Global Protect application, or explicit proxy. This connection is received at a specific Prisma Access location. Once authenticated and connected, the traffic is channeled directly to a dedicated MUSPN, which acts as the security enforcement point. After the MUSPN applies all necessary security policies, the traffic is securely forwarded to its final destination, whether that is the public internet or private applications. This diagram highlights the role of the MUSPN in providing a secure and consistent gateway for all remote access traffic. The MUSPN is vital because it ensures that remote users are protected by the full suite of Prisma Access security features, just as if they were physically in the office. We have clearly identified the function of the MUSPN in securing the mobile workforce. Moving from mobile users, we now examine Remote Network Security Processing Nodes, or RNSPNs. RNSPNs are designed to secure traffic originating from static, remote offices or branch sites. These branch offices typically connect to Prisma Access by establishing a secure site-to-site connection, usually an IPsec tunnel. Once connected, the RNSPNs apply the necessary security policies to traffic flowing in and out of that location, protecting all users and devices within the remote network. For branches needing greater capacity, Prisma Access offers remote network high-performance deployments, which are architecturally distinct and designed to support high bandwidth needs, sometimes up to 5 gigabits per second capacity. A key architectural detail, repeating what we learned earlier, is that data moving between RNSPNs and MUSPNs remains encrypted end-to-end. This ensures confidentiality across the entire cloud backbone, whether the traffic is moving between a branch and a remote user, or vice versa. What is the main point of this slide? RNSPNs provide consistent next-generation security enforcement for all your fixed remote network locations, often connecting via IPsec tunnels and ensuring traffic security at scale. This diagram illustrates how Remote Network Security Processing Nodes, or RNSPNs, integrate into the Prisma Access architecture. The flow starts with the remote network or branch site, which establishes a secured tunnel, often an IPsec VPN, to connect with Prisma Access. The traffic is received at a Prisma Access location, which directs it to a dedicated RNSPN. The RNSPN acts as the security checkpoint for all traffic originating from the branch office. Crucially, the diagram also reminds us that the RNSPN ensures end-to-end encryption for any communication destined for other nodes, such as a mobile user SPN. This network design ensures reliable and secure connectivity for branch users, mirroring the security provided to the mobile workforce. The architecture allows organizations to scale their branch security without managing physical firewalls at every location. We have successfully identified the RNSPN as the node responsible for securing fixed remote network locations and ensuring secure traffic exchange with mobile users. The third core component is the Service Connection Corporate Access Node, or SCCAN. This node, often simply called a service connection, is the critical bridge that connects the vast Prisma Access cloud network to your private internal resources, typically residing in your corporate headquarters or data centers. The service connection itself is established using IPsec tunnels between Prisma Access and your premises. The primary function of the SCCAN is to enable secure access to resources like private applications, internal LDAP servers, and other services for both mobile users and remote branch offices. Essentially, the SCCAN ensures that traffic, once secured by an MUSPN or RNSPN, can safely traverse into your trusted corporate network. Like the other nodes, traffic moving between SPNs and SCCANs is protected by end-to-end encryption. SCCANs are vital for implementing zero-trust network access to private applications, ensuring that only verified users and devices gain access. What did we learn here? SCCANs are the secure gateways that connect the Prisma Access cloud to your private data centers and headquarters, enabling access to internal resources for all secured users. This diagram illustrates the role of the Service Connection Corporate Access Node, or SCCAN, in the Prisma Access architecture. Traffic originating from either a mobile user SPN or a remote network SPN first travels over a secure, encrypted tunnel. This tunnel terminates at the SCCAN. The SCCAN then provides the crucial, controlled connection into the corporate network, granting access to resources located in the headquarters or internal data center. This node is paramount for ensuring that access to sensitive private applications is governed by strict security policies enforced by the SPNs upstream. Without the SCCAN, the secured cloud infrastructure would lack a direct, protected pathway to internal resources. Therefore, the SCCAN completes the connectivity loop, ensuring that security extends all the way from the user's endpoint, through the cloud, and into the data center. We have identified the SCCAN as the necessary component to securely link the cloud security perimeter with the traditional on-premises network perimeter. Let us now consolidate how these core nodes function together to form the complete Prisma Access security architecture. The architecture seamlessly integrates mobile user SPNs, remote network SPNs, and service connection corporate access nodes to provide secure connectivity everywhere. The infrastructure uses a special internal service infrastructure, which requires you, the customer, to supply a subnet. This subnet is used internally by Prisma Access to create the network backbone for communication between all your remote locations, mobile users, and service connections. A critical security feature is the end-to-end encryption of data traffic across the entire cloud fabric. This encryption is applied when traffic flows between an MUSPN and an RNSPN, enabling secure user-to-branch communication. Furthermore, encryption is enforced between any SPN, whether mobile or remote network, and the SCCANs, ensuring that data entering your private network remains secure. This ensures consistent protection and confidentiality across the entire global network, managed by Prisma Access. What is the main structural characteristic we learned? The Prisma Access architecture connects its specialized security nodes, MUSPNs, RNSPNs, SCCANs, using an encrypted, internal service infrastructure built on a customer-provided subnet. This visual uses a simplified Git graph structure to show the core relationships and the security layering between the main architectural nodes. The flow starts with mobile users connected to the mobile user SPN and branch users connected to the remote network SPN. A critical merge point shows the secured encrypted connection established between the MUSPN and the RNSPN, allowing secure cloud communication between different user types. Both the MUSPN and the RNSPN then merge into the Service Connection Corporate Access Node, or SCCAN, confirming that traffic flows from the security processing nodes into the private corporate access point. All these connections are labeled as encrypted, reinforcing the end-to-end security provided by Prisma Access across its infrastructure. This flow ensures that all user traffic, regardless of origin, is processed by a dedicated security node before reaching its destination, whether that destination is another user type or internal corporate resources. We have now seen the integrated architecture, where all specialized nodes work together with robust encryption. Now that we understand the nodes, let's quickly detail the powerful security capabilities they deliver. The security processing nodes are the engines enforcing a comprehensive suite of security features. They utilize cloud-delivered security services, or CDSS, to provide state-of-the-art protections. These capabilities include advanced threat prevention to stop known and unknown exploits, advanced URL filtering to control web access based on site category and content, and advanced wildfire for deep file and malware analysis. A critical function is data loss prevention, or DLP, which protects your organization's sensitive information across all network segments and ensures regulatory compliance. The architecture supports ZTNA 2.0, providing superior security by verifying every access attempt and protecting application traffic, reducing the risk of data breaches. This focus on advanced cloud-delivered security ensures that protection is always current and enforced in real time, regardless of where the SPN is located globally. What is the main point? SPNs are responsible for enforcing the full spectrum of advanced, cloud-delivered security services, including DLP, threat prevention, and URL filtering, ensuring comprehensive protection across the environment. This mind map summarizes the extensive security capabilities delivered and enforced by the security processing nodes. At the core is the Prisma Access Security Suite, which includes high-level services like advanced threat prevention, advanced URL filtering for web categorization, and advanced wildfire for deep malware analysis. The SPNs also handle crucial access control mechanisms, supporting the rigorous Zero Trust Network Access 2.0 model, which secures both access and data, and enforcing all defined security policies. Furthermore, the entire suite is supported by cloud integration, leveraging cloud-delivered security services, or CDSS, for continuous updates and providing real-time protection. These integrated capabilities ensure that every session passing through an SPN is thoroughly inspected and secured against the latest threats. By centralizing these complex functions in the SPNs, Prisma Access simplifies security management for the enterprise while maximizing protection. We have now detailed the comprehensive security offerings executed by the architectural components. To manage this powerful security architecture, administrators use either Strata Cloud Manager or Panorama, depending on their existing deployment and preference. Strata Cloud Manager serves as a unified console, offering a single point of view for managing Prisma Access, NGFWs, SD-WAN, and all other SASE components. For organizations already utilizing Panorama, it remains a viable option for independent management of Prisma Access and its configurations. Regardless of the chosen platform, the responsibility remains with the customer to handle policy creation, configuration updates, and log analysis. All network and security events generated by the SPNs are sent to the Strata logging service. This centralized log storage is crucial for forensic investigations, compliance requirements, and routine analysis, consolidating data from all users, applications, and locations. This centralized visibility streamlines security operations and provides holistic insight into the health and security posture of the entire environment. What is the core learning here? Prisma Access uses centralized management, SCM or Panorama, and stores all operational data in the Strata logging service for unified visibility and streamlined administration. This diagram illustrates the operational flow between the security processing nodes, the logging service, and the administrative interfaces. The Prisma Access nodes, which are the SPNs, constantly forward all their generated network and security logs to the Strata logging service for storage and analysis. Simultaneously, the administrator interacts with the central management interface, either Strata Cloud Manager or Panorama, to define and configure new security policies. These configurations are then pushed down to the active SPNs for immediate enforcement. The administrator completes the loop by actively querying the Strata logging service to view reports, perform forensics, and understand the impact of the deployed policies. This integrated structure ensures that security actions are consistently managed and monitored across the entire global Prisma Access deployment. Leveraging centralized logging for visibility. This unified approach reinforces the ability to manage a massive global security infrastructure from a single pane of glass. The architectural choices underlying Prisma Access yield significant operational benefits, chiefly related to scale and resilience. Because the infrastructure is deployed globally and managed by Palo Alto Networks, organizations gain immediate protection at scale without the complexity of sizing and deploying their own hardware. The architecture is designed for high resilience. Palo Alto Networks ensures the security infrastructure is secure, resilient, and always available. By distributing security functions across many global points of presence, or POPs, Prisma Access places security enforcement closer to the user, which dramatically helps reduce latency. This strategy optimizes performance and increases throughput, which is vital for modern cloud services and distributed workforces. Furthermore, deployment itself is fast and streamlined, often taking hours or days, unlike traditional complex network setup processes. This speed to security is a key advantage of the cloud-native SASE architecture. What is the biggest advantage we learned? The cloud-native architecture of Prisma Access provides massive, resilient scale and low latency globally, freeing the customer from hardware management while accelerating deployment time. This quadrant chart visually compares the operational advantages of Prisma Access versus older models like legacy VPN and traditional MPLS. The y-axis runs from high to low complexity, and the x-axis represents the range from low latency to high scale. Traditional IT solutions generally fall into the high complexity, low scale/latency quadrants. Prisma Access, leveraging its cloud-native SASE architecture and SPNs, is positioned strongly in the global reach and resilience and high performance and agility quadrants. The deployment process for SASE is significantly faster and more streamlined compared to older technologies like MPLS. By abstracting the infrastructure complexity and delivering security globally via distributed points of presence, Prisma Access ensures both optimal performance and ease of management. This positioning reflects the key benefits of moving to a vendor-managed, specialized architecture, where the customer primarily focuses on defining security policy. This visualization powerfully summarizes why the SPN-based cloud architecture is fundamentally superior for modern enterprises.